Okay, right angle triangle related rate problems. So two cars are leaving the same location at the same time. One is going east, so there we can say this is one going east, one is going north. And as they travel in these directions, you can see here that they would be separating from each other as they're going. They're getting further and further apart. How fast are they getting further and further apart at 2 hours? So in this case, we have, if I call this x, ooh, I want to do that in green, it's so colorful. If I call this x and I call this y, and let's go z, or I could do a, b, and c, we know that there's a relationship between these variables. Okay, there's a right angle triangle here. We can create a formula that says a relationship between these variables. What do we want to find? We want to find dz dt. Do we know the other things? Do we know how fast dx dt is? Well, dx dt is due east at 60 kilometers per hour. Do we know dz or dy dt? Yes. That one's traveling at 45 kilometers an hour. So that means each of these variables, if we wanted to write it out, we know that x is a function of time, we know that y is a function of time, and we know that z is a function of time. And in this case, we can set up an equation because we know that x squared plus y squared equals z squared, and then we can take the derivative with respect to time. Since each of those is a function of time, we can do the derivative with respect to time of all of them. And so what do we get? We get 2x dx dt plus 2y dy dt equals 2z dz dt. We're trying to find the dz dt. We have the dx dt. We have the dy dt. And when do we want to find this? Exactly at 2 hours. So we want to find it at t equals 2. Well, there's no place to plug t equals 2 into our equation, but at t equals 2, what does this triangle look like? Okay, it's still a right triangle.
90.
How far is x?
120.
120. How far is y? 90. How far are they apart at 2 hours? A squared plus b squared equals c squared. You know your, do you know your 90, 120 triangle?
Yeah.
Good. What is it?
It's 150.
150.
It's a 3, 5. It's a 3, 4, 5.
3, 4, 5 just multiplied by 30. Sneaky. Okay, so what does that mean for our equation? Well, we're going to have 2 times 120, and dx dt was 60, plus 2 times 90, and dy dt was 45, and 2 times 150, and we want to find dz dt. A little bit of mental math. Okay? There we go. Now, this answer, terribly fascinating, because if we just went to our triangle to begin with and put speeds on there, okay, if I put the 60 kilometers per hour here, the 45 kilometers per hour there. What's the hypotenuse? It's another 3, 4, 5 triangle. Everything times by 15, 75. And is that just coincidence that that matches up, or will this always work and I've kind of ruined this question forever?
We do this in physics. It's like vector addition.
So will it always work? Will they? And then if it will always work, that also means that it doesn't matter what time, they're always going to be separating at 75 kilometers per hour. Okay, so, well, how would we figure that out? Would it always work at any time?
We can take out the time because it's on all parts of the equation.
So on all parts of the equation, right, this x is just speed times time, right? And this is speed times time, and this is speed times time. So we could put that into the equation. Instead of putting 120, this is 60 times time, right?
Yep.
Times 60, plus 2 times, instead of 90, that'd be 45 times time, equals, and instead of 150, well, can I put 75 times time in there? Yes, because whatever distance they'll be apart, it'll be,
I think you missed the second 45, right?
it will be 75 times time. Did I miss a second 45? This is a plus sign. Yes, there would be another 45 in there. And then times dz dt.
That's so cool.
And if you work this out, sure enough, dz dt is equal to 75 kilometers per hour. So it will not matter. It will not matter what time. They will always be separating at 75 kilometers per hour. Okay? Now, despite that, this is still a nice setup to see. Despite the fact that we could have just done 45 squared plus 60 squared equals 75 squared, in order to prove it, we still had to go back to what idea is happening here. And we had to set up a squared plus b squared equals c squared in order to do this related rate problem. Good?
Mostly.
Mostly. This is exactly the same question with different things, so we'll skip it. Save some time. It's just another x squared plus y squared 1 with not as nice numbers. But this one looks more entertaining. A 20-foot ladder leans against a house. Find the rate at which the top of the ladder is moving downward if the foot of the ladder is 2 feet away from the house and moving away at a rate of 2 feet per second. This would not be a very entertaining ladder to start climbing. Because as you're going up, you realize you're going down. And then then you have to make it, what decision do you make at that moment? So we draw a picture. Here's the house, right? Nice window right there. Maybe a door down here. Perfect. And we've got a ladder. Now, you decided to put the base of the ladder. You bought a new ladder that had rollers on it. Not a very good strategy. And what is happening is the ladder is traveling this way at a rate of 2 feet per second. So as far as what do we know that dx dt is equal to 2. So I'm going to call this x. I'm going to call this length y, and we want to find dy dt. Now the way that I've drawn this, can you see that your x value is getting larger?
Yeah.
So in that sense, my dx dt being 2, a positive 2, makes sense because it's getting larger. When we solve for dy dt, since it's going down and y is getting smaller, we should get a negative value to show that it's decreasing. Find the rate at which the top of the ladder is moving downward if the foot of the ladder is 12 feet from the house. So when we set up the equation to begin with, we set it up with our variables. What do we know in this case? We know that x squared plus y squared is equal to 20 squared, and that 20 stays constant. It does not change. So no need to put a variable in for your hypotenuse in this case, because we know it's always going to be 20. And so x squared plus y squared equals 400. Now, when you take the derivative with respect to time, of course, x is a function of time and y is a function of time. Well, this becomes 2x dx dt plus 2y dy dt equals 0. Now, we're trying to find it when the ladder is 12 feet away from the house. So we're looking at this situation. Here's our ladder. At the moment, it's 12 feet away from the house. Do you recognize the triangle? It's another right-angled triangle. Excellent. Love it. And so you could do a squared plus b squared equals c squared and find out that this is 15. It's another 3. No,
Yeah, I was like, that's not.
not quite. 16. There we go. Another 3, 4, 5 triangle. And so we can plug in what we know. dx dt was 2. At y is 16. dy dt is what we want to find. Equals 0. Moving the 48 over to the other side and dividing by 32. Divide both by 16. And what are our units?
Feet per second.
Feet per second. Negative 1.5 feet per second is how fast the ladder is going down.
Which means you have a good amount of time before it actually.
Yeah. Now, probably in a real-life example, it wouldn't stay at a constant speed moving out. It would probably increase in speed as you're going down. But in this case, maybe this ladder with the wheels, these were motorized wheels, and you accidentally turned them on so that it would go away from the building at that constant rate. This is a very realistic situation that we're thinking about. Yeah.
I mean, I have that happen sometimes.
So, yeah. Don't buy ladders with wheels on either end.
Would you like a ladder?
Real men use ladders.